Let's look at direct variation. Direct variation is a specific relationship in which there is a constant ratio between all ordered pairs, all of our x's and our y's. And our equation looks like this. Let me do this. Y equals k x. And k is just some number that would be given to us. Remember, our y is our input. Our x is our input and our y is our output. And so in order to solve these, we are going to set up a proportion. And our proportion is going to look like this. X over y equals, again, x over y. So this is the important part to remember, that our x's are going to both be on top and our y's are both going to be on bottom. We cannot mix and match here. So we are given, if y equals 25 when x is 10, find y when x is 65. So let's set up our proportion with our x is on top and our y is on bottom. So we've got x is 10 when y is 25. So we always put what's given to us in the first proportion, and then that's going to equal, we got x is 65, and we want to find out what y is. So then y goes here. And then we just solve. You guys might remember this as cross multiply and divide, the butterfly method, something like that in the past. And you most certainly can do it like that. I'm going to, though, don't we have one equal sign and one variable? I can try to adjust this. Focus. Okay, I'm going to use my menu 3-1, my numerical solve, and I'm going to type in this exactly like I see it. So remember, we can press Control divide sign to give us a fraction, a top and a bottom. So we've got, I'm going to put 10, arrow down, 25, arrow over to get back to the main thing, equals, again, Control divide, so I get that other fraction, 65 over y, arrow over again to do my comma y. Remember, if I use a y here, I got to use a y there, equals. So here, when x is 65, y equals 162.5. All right. So I got another example so that y'all can see how it's done. Again, if y equals 16 when x is 24, find x when y is 92. So we're going to set up our proportions. X on top, y's on bottom. This time we don't know x, so my variable goes on top, and we know y is 92. So when I put that in here, menu 3-1, Control division sign, 24 over 16 equals x over 92, comma x. Here we've got x equals 138. All right, the only time this might get tricky is when I throw some word problems at you. So whenever I'm given word problems, we're not given it in terms of x and y. So we need to label one as x and label one as y. and then make sure we set up our proportion properly. So there are 18 female students out of a class of 30. At this rate, how many female students would be in a class of 100? So I'm going to go ahead and just say my number of female students is X out of my total students, Y. So then we want to know how many female students, that's our unknown X, in our class of 100, total Y. So we've got 18 over 30 equals X over 100. And whenever I put that into numerical solve, we've got X equals 60. So when we had a class of 100 students, we would expect 60 to be female students. So that's what this direct variation is all about. It's about predicting something based on what we know. So it rained 24 inches in a 10-hour period. How many inches did it rain per hour? So I'm going to just say inches is X. So then how many inches? We need to find that out. Y would be my hours. And it says per hour. So per hour means in 1 hour. So we want to know how much did it rain in 1 hour. So we got X of 24 over Y of 10, X unknown over Y of 1. So when I do that, then we've got X equals 2.4. So in 1 hour, it rained 2.4 inches.